Read through on page 586 paired data and using the one sample T procedure. I'm not going to read through the first paragraph. You can do that yourself. The point is, we have a table here. There's some kind of a reading in integers for people taking, having a certain condition, taking caffeine, taking a placebo, and a measurement is made, and an integer valuation is ascertained. And now in this case, there are only 11 subjects. Now once for the placebo and the caffeine, the 11 data points are established, there's another column which is the difference. Okay, so the problem is, first of all, the methodology of this was that the researchers randomly assigned the order in which the subjects received placebo and caffeine. So I'll read about that. That's an important part of this paired stuff. The order in which they take it cannot be regular because they want to avoid, so for example, if they do it all in one day and they're trying to detect that is the effect of whatever it is they did that really is what caused a certain result. If they do everything on one day without any randomness, it's possible that there could be a confounding factor that causes the result, not the caffeine or the placebo. And then carry out a test. Okay, 4-step process. Once again, always check the conditions. First, state the null hypothesis. If caffeine deprivation has no effect on depression, then we would expect the actual mean difference to be 0. Therefore, so no effect corresponds to the mean difference being 0. So the hypothesis is the mean of the difference is 0 versus the mean of the difference is greater than 0. Now they're subtracting the caffeine from the placebo, so it would mean that the result of the placebo is greater than the caffeine if it's greater than 0. Okay, so the conditions, random, of course, 10%. Well, since there wasn't a sample, this was an experiment, it's not necessary to check the 10% condition. Please take note of that. Okay, once again, since the sample size is less than 30, they must go in and check, and you're usually going to come up with something that allows you to proceed rather than something having strong skewness. I mean, in this one, the histogram doesn't exactly look all that great, but the box plot is kind of symmetric, and there's a slight curvature to the normal probability plot, but apparently not enough to reject this procedure of using a t-test. Okay, so they come up with a test statistic of a t-value of 3.53, a p-value of 0.0027, with a degrees of freedom equal to 10. Okay, so, and please note also that when we do it on the calculator, you don't use the degrees of freedom, but you should take note of what they are on the AP. What's the conclusion? The p-value of 0.0027 is less than 0.05, so we reject. We have convincing evidence that the true mean population is positive for subjects like this. In other words, we accept the null hypothesis.